In this example, which is number 7, we want to find the antiderivative of sine 4u. Now there's two approaches to this. One is to guess at it. Okay, so we could say, well, what is the antiderivative of sine? Okay, so I'll give you both ways here. The first way would be to guess at it. So we would say, well, what is the antiderivative of sine? Where does sine come from? Well, we know that sine comes from negative cosine. So for example, if we let, I use the same variable here, if we let the antiderivative as a function of u be equal to negative cosine for u, that might be a guess. So let's go ahead and differentiate this guy and see what happens. Well, when we differentiate this, we use the chain rule. And the chain rule says we take the derivative of the inside with respect to u, which is 4. The negative stays out in front. Then we take the derivative of cosine, which leads us back to negative sine 4u, which would give us 4 sine 4u. So the derivative of this guy is not quite what we wanted. It's 4 times as much. So what we're going to do is we're just going to divide this guy by 4. And that will correct for the error. So let's put a plus c on there. So now if we take f prime of u, we're going to get negative, then the 4, then the negative sine 4u over 4 plus 0. So negative times a negative is positive. 4 divided by 4 is 1. So we get sine 4u, which is exactly what we wanted. So this guy right here is the antiderivative. Now we had to just play around with a little bit and guess. And honestly, that's really what antidifferentiation is about, is trying to play around with what you've got on the inside and manipulate this, okay, from here to here, manipulate this guy so that when you take the derivative you get this. It is kind of a guessing game. You can think about it like when you're factoring, sometimes you're guessing at it, like what do I factor out here? Now there's another way to do it besides guessing, and this is going to be what we call substitution. So for substitution, I'm going to replace 4u with a different variable. Let's call it theta. Okay. Now what does this give me? Well, if I use my if I just go ahead and play around with this, I could say this is u is equal to theta over 4. Okay. Now, using our differentials, we get the following. We get that du is equal to the derivative of this guy with respect to theta. So essentially we get du d theta. So du is equal to du d theta times d theta. So the derivative of this guy, which is u, with respect to theta, is going to be 1/4, and then d theta. So this is our differential. Now we're going to use that to substitute in here. So watch. And we'll say this is the integral of sine theta. So we're replacing 4u with theta. But now we have this du at the end, and we need to replace that. So this will be sine theta. Now du is 1/4 d theta. And so if we take and multiply the 1/4 out front, and the key thing here is that the variables match. I can't differentiate this with respect to u here if I've got theta in here. So I need to make these guys the same, and I'll use my differentials to do that. Now this guy is pretty easy to find. We know that to go backward from sine, that goes to cosine. So what we have is 1/4 goes back to negative cosine theta plus our constant. So we went backward now. But theta is 4u, so this is 1/4 negative cosine 4u plus c. Now you might say, well, shouldn't it be 1/4 c? Well, you can write 1/4 c if you want to, but it's still just a constant at the end, so it doesn't matter. Okay. And so if we go ahead and distribute that in, we can write this like this. Cosine 4u negative over 4 plus c. That is our antiderivative. And it gives us the same thing here. Now, the difference between these two techniques, the guessing and the substitution, is the substitution works pretty flawlessly. You don't have to do as much thinking. We're just replacing variables. The guessing here takes a little bit more work, a little bit more creativeness, okay? But you don't have to play around with the variables as much. So they both have their advantages. Now, most people will do this route for substitution once they get used to doing this anti-differentiation. Because sometimes the problems get too hard where you can't really guess, or it would take you too long to guess. So we use this technique here. You want to get familiar with doing it both ways. Okay, so on each problem, try to guess, and then try to do a substitution and see what happens. And the more you try both of them, the better you're going to get at anti-differentiation. And that's what's important here. Okay, so don't just say, well, this substitution thing was kind of confusing. Take your time and think about why we wrote down the things we did and how we replaced them, because this technique is used a lot in problems where it's really too hard to guess.